Okay, hello. Now we're going to move away from VMware and VirtualBox, and we're going to go into the second part of the module essentially, which is OpenNebula. We will essentially build our own little cloud in our computers and learn the basic principles of how to actually build one and how a cloud actually works. We will be using OpenNebula in order to do this. OpenNebula is one of the two biggest players together with OpenStack in free cloud solutions and open source cloud solutions really that are used today. And I will explain a little bit of the basic principles of how clouds actually work, and then I will go into details about the installation of OpenNebula onto your system. So essentially, I will go through the first lab sheet. So a cloud, by definition, a cloud is a resource that is available to its users remotely so that they can work on it with minimal hassle, with minimal management skills. Basically, it's the easiest and most efficient way nowadays to give your users the resources that they need in order to do their job. And when I say resources, I don't necessarily mean a computer in itself. A resource in the cloud world will mean anything from CPU cores to amounts of memory to amounts of RAM to just hard drive space and so on. The simplest concept of this, for example, if you are using an Android phone, you have a Google storage space, you have a Google Drive, or if you are using an Apple device, you have an iCloud that gives you so much storage. That storage is provided somewhere on a cloud on the respective two companies. So as a resource, you're getting some storage space for your phones on the cloud, and that's basically, it's the most basic principle of what it is. In a more elaborate environment, you would have perhaps a company that has users that are either working in the premises of the company or are working remotely, and all they need to do is they have a computer and they just start it up, computer or a laptop rather, and they just start it up and they log into a computer, to a virtual machine that's running somewhere on a cloud, possibly on the other side of the world, and they can connect to it and work on it. And in fact, they don't even need to have a computer. They can sit on any computer in an internet cafe or whatever, go into a browser, start a remote section that is secured with VPN and everything else, open up a computer inside that browser, and actually start working on it and do their job. All right. So a cloud has some basic principles of operation, some infrastructure that exists there in order to offer those services to its users. At its core, it consists of the elements that we see in the diagram here. So first of all, we will have a front end. So we will have a computer, a server running somewhere, possibly even inside the cloud itself. That gets fun later on. That's running the software that manages the cloud. All right, the front end. The management interface, so for whoever is administering the cloud, so they can actually allocate resources to users, troubleshoot, upgrade, manage, and so on. That front end can be a computer in itself. It can be a server that's sitting somewhere that is irrelevant to the cloud itself, or it actually can be inside one of the hosts that actually run the cloud itself. It depends on the scale of the cloud, it depends on the size of the cloud, and how you as a system administrator want to actually manage the system. The second most important aspect to a cloud are the virtualization hosts. The hosts themselves are the servers, the physical devices that will allow for virtual machines to run. So they will allow our computers inside our cloud to actually run. They will provide the CPU cores and the memory, the RAM, that your virtual machines will need in order to start up the cloud. So when we say that our cloud has 800 cores, it probably means that it has so many computers that can run a multiple of so many cores, and that's how it actually happens. That's how it exists. Now, you also need some storage space for all of this. So at some other point of the cloud, you will have your data store, so you will have your storage device. You will have your storage servers that will be physical servers whose only purpose in life will be to actually have hard drives so that they have storage space for you to use in the cloud. Okay, nothing else. No virtual machines run in there. We don't use the cores or the memory from these servers. We just use the storage space as allocated by the data stores that we have. All these need to connect together, so they need to connect with each other so that they work. So we have what we call a service network in between. The service network is the physical network that connects all of the servers that will actually make up our cloud. So all of the physical devices that will actually take part in our cloud itself. And we have finally another type of network, which is the VM network, which is the virtual network inside the cloud itself, and that will provide connectivity to all of the virtual machines in your cloud between them and to the outside world. It all depends on the type of setup that you have, whether, how individual virtual machines will communicate with each other or not. So if you have lots of virtual machines in the cloud that are actually network in the same segment that are supposed to access each other. So for example, you might have, let's say, a company network that has a virtual server in the cloud and it provides virtual workstations for its users. So its users not only need to be able to access those workstations from outside the cloud, those workstations themselves need to be able to access the company's server as well to get information from it. So the virtual network in there will perform those two tasks. It will connect the virtual machines to the hosts and through the service network to the outside world, and it will also connect those virtual machines between them and with the company server or even the workstations between them as well. Okay, in our setup in the lab, things will still operate under these basic principles. However, they will be much more simplified because all of these components will essentially run on the same computer. So you're all working on one computer on the lab, and that one computer will basically be the front end for OpenNebula because that's where you install OpenNebula. It will be the virtualization host, so your Prometheus virtual machine will be what actually has the ability to start up virtual machines and run them inside the cloud. And that will also provide the storage space, so that will also provide the data stores for the cloud itself to work. You will also create virtual networks with OpenVSwitch later on. So those will be the VM networks that you will use for your virtual machines to communicate between themselves and to the outside world. And the service network as such doesn't really exist. It really is the ENS33 network card that connects your Prometheus virtual machine, your host for everything, to the outside world, essentially. Okay, so things will be more simplified, and because of that, we can do away with a couple of networking requirements. So, for example, for the data stores to communicate with the front end, MySQL server installation normally needs to take place, so you don't need to do that. Okay, password SSH, for example, and everything else is much simplified because everything is happening on the same host and so on. So the basic principles of operation will still be there, but everything will be much more simplified because everything will be happening on the same computer, on the same host itself. And to add insult to injury, that host is actually a virtual host as well. Okay, so you will have an actual computer, which is the computer that you're working in the lab, that has a virtual machine that will be your virtualization host and server, and inside that virtual machine, you will have a cloud in which you will build virtual machines. So we'll be going 4 levels in, really. Okay, however, that allows us to be able to work on this, even at the university or remotely, and to add maximum redundancy to this. So I can tell you from now that every time that you complete a lab sheet, or something important that you do, or you want to make some important change, make a backup of your Prometheus virtual machine. Your computers themselves have 2 terabytes of storage, so there's plenty of space, and it's unquoted. Okay, so you don't need to worry about running out of space. If you do, for example, complete the first 3 lab sheets, and then you want to go into OpenVSwitch, take a backup. So the easiest way to take a backup is to actually go into your host, find your TP2 Prometheus VM, make a copy of it. Okay, in the same VMware folder where it lives, make a copy of it, name it TP2 Prometheus Lab 3 Complete, and then keep working on your original Prometheus virtual machine. If you break something, if it crashes, if something goes horribly wrong, you can revert back to your backup and then you won't have lost the rest of your work on that virtual machine. Okay, this is even more important at the end of the fourth lab set, so at the end of the Open vSwitch lab set. If you do manage to go on to the last lab set, which is building the virtual network, it's a very good idea to take a snapshot essentially of the system at the end of the networking, at the end of the OVS lab set, so that you're sure you have everything up to there, because that will cover the main bulk of what is being assessed in the module. And then you can go on to the last lab set and you can play around as much as you like without having any fear that you might break something, and then come assessment day you might not have a virtual machine to work with. All right. I won't go through this document. It is on Moodle, so you can go through it and see all of the basic, all of the details that you need to know about OpenNebula and how it actually works. I will explain the installation of the software so that we get started. So, the easiest way to install OpenNebula, because there are a lot of dependencies, is to actually create a repository in the system and tell it exactly where the software is actually located on the internet, and let your host go fetch it. Okay. Now, on the virtual machines that you will have, some of the information in this lab sheet might already have been done or not. Has anybody in here actually done this first lab sheet? Yes. Was this repo file already there? Okay, so I've done this because a few things can go horribly wrong here. We wouldn't know about them. We would know about them in the third lab sheet, by which time it would be too late. All right, so some of the tasks in here are completed. You still need to go through everything. The idea is that if something is there, take a screenshot of it and leave it alone. Okay, so for example, this OpenNebula.repo file will already be available on the system. I made it, it's correct, it works because I've tested it. Just take a screenshot of it, say the repo file has been created, it's there, and explain basically in the screenshot what the repo file actually does. All right, so if a task has already been completed for you, you will still of course get the marks. It doesn't mean that I don't give you marks for it. However, I do expect you to understand what's happening in the step, and I do expect to see an explanation of this in the logbook itself. Okay, so for example, this step, get a screenshot of the repo file, put it in your logbook, and say this is the repository for the OpenNebula installation, and this basically will tell our system where to go and find OpenNebula. So once this file is in place, we need to run yum make us and yum install EPEL release so that our CentOS installation will read this file and will update its database of available repositories in the system, so that later on when we go and do yum install OpenNebula server, Sunstone, Gate and Flow, it will simply be able to go on to the address. So if you actually have a look at the file itself, you have base URL, downloads, OpenNebula.io, repo 6.2 and so on. Another important thing, we're using version 6.2 of OpenNebula. OpenNebula is at the moment on version 6.6. However, that works better for Red Hat Enterprise Linux versions 8, 9, and so on. Okay, so because we are using 7, I have used the previous version of OpenNebula as well. The differences for what we will be doing in the labs are not there. There's nothing that's too different or too improved in the newer versions. It does have some additional features and everything, but we wouldn't be using them in the labs anyway, so there was no point going with that. So once you run yum make us and install release, and once you install OpenNebula server, Sunstone, Gate and Flow, all of the components should be installed in the system. In fact, in the terminal, you should see already installed, nothing to do. All right. The first important business is to make sure that you set the password for your administrator user. So the administrator user is called OneAdmin. Everything in OpenNebula are called one something from OpenNebula. Yeah. Excellent. Wordplay. Anyway, so OneAdmin needs to have a password of localhost 1. That password on an initial stage gets set at a file that exists in the OneAdmin's home directory, which is in .1 and it's called one_off for authentication. All right. So all that echo command does is it puts the words one admin colon localhost 1 into that file. So if you do open that file, you should be able to see that it only says one admin localhost 1 inside it. This means that the admin password is set at this stage, and once you do that, if you start the services, so if you start OpenNebula and OpenNebula Sandstone and decide to change the password after that, the process to change the password is different. Okay, because then once you start the services, the OpenNebula files will be read, this one auth file will be read, and the password for this user will be built into a database into the system. And in order to alter that database, you cannot just alter the contents of this file and restart the service. You need to actually type the appropriate command, which is one pass WD if I remember correctly, in order to change the password for the admin user. All right, so be very careful about this step. Make sure that you basically just copy and paste this command onto the terminal, and it goes into the OneNote file, and that's done. Once that's done, we then need to open our Sandstone server file. So yes, perhaps I should go into a bit more detail about this. Two main components we will be working with. There is an OpenNebula and an OpenNebula Sandstone. The OpenNebula is the main daemon, the main program that runs and manages the cloud. Okay, so everything that happens in the cloud is done by user one admin from the system process that belongs to OpenNebula. There is another very important system process on it that's called OpenNebula Sandstone. Sandstone is the web interface into which you can go and manage your cloud, where you can go and see how many cores you have available on the system, how much RAM, how much hard drive space, create your virtual machines, and start them up, stop them, and so on. Sandstone itself is not a requirement for the cloud to run. If you were a hardcore Linux administrator and your server didn't have any graphical user environment, you wouldn't need OpenNebula Sandstone to run there, because you wouldn't need to administer your cloud in a web interface. You can actually do it on the command. There's a CLI as well, so there's a command line interface for it as well. Okay, so Sandstone exists just to make our lives easier, essentially, so that we can manage everything on a browser interface. So because that's what Sandstone is, that's why I am asking you to go into the Sandstone server config and make sure that you remove the FireEdge component of this. The FireEdge component is another system management component, so it does exactly what Sandstone does in a different, more fancy way. But for the purposes of you familiarizing yourselves as a first contact with the cloud environment, I have basically taken away fancy features like that you don't need to worry about too much. I would prefer that you learn the basic principles and learn how to operate the cloud itself, rather than looking at additional optional features into this that don't really have to offer that much. So make sure that there's a hashtag in front of the last two lines in that config file, so that FireEdge is actually disabled and doesn't actually try to start, because if it does try to start, there are other components that we haven't installed, so you will get a problem when you try to do the next step, which is systemctl start OpenNebula and OpenNebula Sandstone. Now, once you run this command, you're essentially running the services on the system, and you can go into a terminal, and as I said, there is a CLI that you can use. So if you type the command one user show in a terminal, that will basically connect onto your OpenNebula server and ask to show all of the current users in the system. Current users in the system are only one. It's a user called OneAdmin, and you'll get all of the information about OneAdmin in the terminal where you are. So that is confirmation that your OpenNebula service is actually working, and that you have successfully created one user called OneAdmin in there. Once you do that, you can also go onto your browser. You can basically click on this link here in the lab sheet, and it will take you onto the Sandstone interface. So it will take you onto the website in localhost 9869, wherever it is, and you'll be able to log in as OneAdmin password of localhost 1. Please save that password to make your life easier, because you will need to log into this a lot of times by the end of the semester. All right. and you can log in and see all of the available resources in your system and actually start working on your cloud there. There is some directory structure here as well, which is here for information purposes. So the configuration files for the service exist in etc1. The home directory for the users are in var lib1 and so on and so forth. You can see where some log files are as well, in case you need to troubleshoot the system later on. It's just there for information only, essentially. And we can move on to the next part. The next part is to give your Prometheus virtual machine the ability to run virtual machines for the cloud. So we need to make it a KVM node. KVM is a virtualization hypervisor, all right, and this is the type of virtualization that your OpenNebula cloud will support by default. So all of the virtual machines that you build and run inside your cloud will be built and will be running on KVM itself. So once you do yum install OpenNebula node KVM, service libvirt restart to restart all the virtualization services in the system, then your machine will be able to run virtual machines inside the cloud. If you forget about this step and you try to build your first virtual machine and click on instantiate, it will not do it because it cannot start the virtual machine. The next step is to configure passwordless SSH. This is one of the steps that students usually get wrong, and this is one of the biggest reasons why I would have done this step for you. Okay, so I need you to SU to user one admin. So once you switch to one admin, you can basically see your config file for your SSH service. Okay, SSH is configured on the system by default. The config is a default configuration file, and in that file, you need to make sure that those 3 lines exist, and they are like that. Strict host key checking should be turned into no. It should already have been turned into no, yes. And you must have this line user known hosts file /dev/null, which basically tells your SSH server to log in your one admin user without asking for a password. This is done because the one admin user, which is a system user, will need to be able to log in without being asked for any input from you as a user into all of the various virtual machines and services that are running on your system. So the first thing, for example, to happen will be later on when you create a virtualization host in the cloud, that host needs to be contacted by OpenNebula. So your one admin user needs to be able to log in there, go fetch information so that it can monitor the system and go back. You shouldn't be asked for a password every time this happens. There is no provision for it. Okay, so this is enabling passwordless SSH. This is making your one admin user able to actually log into all of the computers in the cloud, most importantly our virtualization host, without being asked for an SSH. If this is wrong, if this file is wrong, then your virtualization host inside OpenNebula will not be able to run. It will not be able to be turned on, so you will not be able to run any virtual machines inside your cloud. Save the file, the instructions are there. It is in VI because you have SU'd into it, so you cannot use graphical editors like gedit. Okay, so that's why we're using VI in there. Once you do this, and once you make sure that the permissions are set correctly, so make sure you type this command mod 600 for the SSH config file, you should try to SSH localhost. So essentially at that point, you're still user one admin, and you're trying to SSH into yourself, into existing computer that you're already logged into localhost. That should happen. It should say, SSH completed or done. It shouldn't ask for a password or anything, and that's basically proof that your passwordless SSH works. You should then do exit to log out from this SSH, and then you should do exit again to log out from user one admin and find yourself back as user root in the terminal. So at the end of this, you should be able to basically go onto the web interface, and you should be able to log in as user one admin and see everything that's available in there. All right, and that is the last part of the lab sheet. What sort of information can you see in the dashboard area? Write a small paragraph and explain, I can see the various categories of resources on the cloud. So I can see networks, I can see storage, I can see virtual machines, templates, and everything else, and see what these actually mean. Have a look around, play around with the web interface a little bit, and try to figure out what everything actually does. Okay? Do you have any questions about any of this?